Okay, so we are now going to learn how to count atoms. So it says here, number 1, the symbol, so the chemical symbol or the chemical formula of an element represents one atom of this element. So in this example, we have Cu, which is the symbol for copper. Whenever you have an element that has just the symbol, no numbers, no subscript, that always means one atom of that element. So when you don't see a number, so I'm just going to do another example here. If I was to put Al for aluminum, actually going to try that one more time. If I was to put Al for aluminum, that is one aluminum atom. So a lot of the time we look to the subscript that's behind the element symbol. In this case, we don't see a subscript, but there's really always like an imaginary one beside the element. So even beside this copper here, it's like an imaginary one. If you don't see a number, it's always a 1. So in this case, we only have copper and there's one copper atom, or we only have aluminum and there's one aluminum atom. Number 2 here says, the subscript is a number written in the lower right-hand corner behind the symbol of the element. If there is more than one atom of the element in the molecule, then a subscript is used to indicate the number of atoms. So the subscript in the lower right-hand corner behind the symbol is always going to represent the number of atoms of that element. So in this example, we have a subscript of 2, so that means that we have 2 nitrogen atoms. Okay, so I'm going to write that here, 2 nitrogen atoms. Okay, another example would be if you had O2, same thing. The lower right-hand corner behind the symbol, there's going to be a subscript. In this case, it's a 2. So this is saying that there are 2 oxygen atoms. Okay, so far we've seen that if there is no subscript and it's just the element symbol, that always means 1. Okay, if you don't see a subscript, that always represents 1. We just don't write it. And if there is a subscript, then that is what you're going to look to determine the number of atoms. Okay, number 3 here says, a coefficient is a number written in front of a chemical symbol. Okay, a coefficient is written in front and indicates the number of atoms of the element. So in this case, we have 3 in front of the C. So first of all, this C is representing the chemical symbol for carbon. And now we have a coefficient. So that's a number written in front, not a subscript. So in this case, that 3 is representing the number of atoms of the element. So we have 3 carbon atoms here. And if we want to take it one step further, if we were to rewrite this, so I'm going to put a C to represent that carbon symbol. And because we don't have any subscript to the right of it, we know if it's not there, it really is a 1. Okay, so we don't write the 1, but I'm just showing you that that really is a 1 there. And then we have this coefficient in front of a 3. So in order to get the number of atoms, you take the subscript, which in this case is really 1, because if we don't see it written, we know it's a 1, and you multiply it by the coefficient. So this is like 1 times 3, which gives us our answer of 3. Part B here says, a coefficient is a number written in front of a chemical formula and indicates the number of molecules in the compound. So these ones are getting a little bit more difficult. So if you look at this example here, we have 2 H2O. So that first 2 is representing the coefficient, and that is representing the fact that there are 2 water molecules, 2 molecules of H2O. So now we almost have this extra step here when trying to count atoms. So when you have a compound and not just a single element, you want to break down that compound into the elements that make it up. So in this case, we have H, 2, and O. So the 2 elements that make up this compound are hydrogen and oxygen. Okay? The first thing that you do is look to the subscript beside the element symbol. So the subscript behind the hydrogen symbol is a 2. So we originally start out, so I'm talking about this 2 right here. Okay, so that's attached to the hydrogen element. So that's saying that there are 2 hydrogen atoms there. So that means that we're gonna, and I'm just gonna write this out so that you can kind of see how we came to this answer. So that means we start with 2 hydrogens, but then you have to take the subscript and multiply it by the coefficient. So this 2 and that 2 are going to multiply by each other. So 2 times 2 is going to give 4 hydrogen atoms, okay? And that's why we have that answer there, 4. Oxygen, again, we're still going to look to the subscript behind it. So in this case, guys, there's no number written. So what did I tell you? If there's no subscript there, we know it's really a 1. So we're going to start out with 1 oxygen atom, but then we always have to multiply by the coefficient. So this is going to multiply as well. So we're going to do 1 times 2 for a total of 2 oxygen atoms. Let's try this next one. It looks a little bit more difficult, but again, we need to break down the compound into all of the elements that make it up, and then we will do our multiplication if we need to. So in this case, we have iron sulfate, FeSO4. So we have iron, okay, so Fe, and if you are struggling to break up the compound into the elements it's made up of, keep in mind that every element starts with a capital letter. So since the E is lowercase, that's still combined with the F. So Fe is the symbol for iron, okay? And then S, okay, is the symbol for sulfur. And then O, okay, and notice the O is not lowercase, so it's not attached to the S. It's not one symbol. It's another element. It's capital, so that means a new element. So our third there is oxygen. Okay, so keep in mind we're going to count atoms for each element that makes up the compound. So iron, first we look to the subscript. So remember, if there's no number to the right or behind the symbol, that means it's always 1. So this is really like an imaginary 1. Beside the S is also like an imaginary 1, and then beside the O we see that subscript of 4. So when counting atoms for iron, we start out with 1, because that's the subscript beside iron, and then we have to multiply, okay? We have to multiply that 1 by the coefficient. So we're going to do 1 times 3 for 3 atoms. Then we're going to do sulfur. So again, what's the subscript? We start out with 1. We have to multiply by the coefficient to get 3. Oxygen begins with 4 atoms because we see the subscript beside the O is a 4 now, but we have to multiply the subscript always by the coefficient. Our coefficient is 3 to get 12 oxygen atoms. Okay, so we're going to look at these examples here. The example is already done, but we're going to go over the steps as to how to get here. So we have Na2CO3. So the first thing we want to do when counting atoms is break down the compound into the elements that make it up. So Na represents sodium. Okay, so we have sodium here. C is carbon, and O is oxygen. And remember, guys, you have your periodic table, the reference sheet that will help you to determine that. So sodium, carbon, and oxygen. Okay, remember that A is attached to the capital N because any new element is always going to start, its chemical symbol is always going to start with a capital letter. Okay, so if there's a lowercase, it's attached to the uppercase that's beside it to the left. So we have sodium, carbon, and oxygen. So you'll notice here we don't have a coefficient. Okay, so we don't have to worry about having to multiply by a coefficient because there's no number in front. So before you'd see like a number in front here, just like over here, okay, in front of the BaCl2. We don't have a coefficient like that for our first example. So we don't have to worry about multiplying. We're just looking at the subscripts that are behind the symbol or in the lower right-hand corner. So how many sodiums are there? Well, if we take a look here, the subscript beside the Na is a 2. So that's saying that there are 2 sodium atoms, okay? That's how we got this 2 here. Beside the C, remember the C and the O are different elements, okay? So we're looking directly to the right of the C. There's no number there. We now know that that really represents a 1. So that's why we have a 1 carbon atom. And then to the right of the oxygen symbol is 3 to tell us that there are 3 oxygen atoms. We add those together, get 6 total atoms. Let's try this next one over here. So we have a coefficient of 3 in front of the compound. Okay, so have this 3 here that we can't forget about. And then we have BaCl2. So this says barium chloride. First thing we have to do is break it down into the elements that makes it up. So Ba represents barium. Okay, so we have barium. Actually going to use a different color that's not as dark. Okay, so we have barium, and then the Cl represents chlorine, keeping in mind that A is lowercase, so that's attached to the B, so that's one element symbol, Ba, and then Cl, L is lowercase, so it's attached to the capital C, and that's a second element symbol. So you'd find Ba and Cl in your periodic table, you would get that that's barium and chlorine. When counting atoms, first we look to the subscript and then we multiply the subscript by the coefficient. So if we look to the right of the Ba symbol, okay, there's no number there, so we know that that really means that there's 1 barium there. We have to multiply that 1 by the 3. So we have to multiply, okay. I'm actually going to fix that because that is messy. Okay, so actually going to use black here to show the 1 barium, and that needs to be multiplied by the 3. Okay, so we are really doing 1 times 3 here to get 3. Chlorine, we're going to look to the subscript, so beside the Cl we see a 2 here. Okay, but we then have to multiply that 2 by the 3. Okay, so it's really like doing 2 times 3 is going to give us 6 total atoms. You add the 6 and the 3, we get a total number of 9. Okay, so that was our practice with counting atoms. Again, we will review this during the review lesson on Teams. If you have any questions, we'll do some more practice together. In the meantime, you have a practice page in your booklet on page 27.